All right, so in ice, what happens is basically these water molecules are tightly compact together, right? They're like fairly close by because there's less movement, right? Each water molecule, let's say this is not going over there, this isn't going there, right? And like they're stable. They're not as they're not as much in motion, right? So they're very stable. The water molecules, the ice molecules, the water molecules here. So what happens with these is that they basically form a tight like structure resulting in ice that has good hydrogen bonds. So unlike the water molecules, they don't like slip and slide like this. The ice molecule, the ice what it does is that it helps like it compacts the molecules together, which doesn't make them like slip and slide here and there, right? And once they're like stable, what they do is basically, let's say I have one molecule here and another one here, and both of them aren't moving. So what they do is they like stay in place for longer, while these ones were like easily breakable, right? You could just like they would slip slide here there and they would like move close together, this that very much was happening here. Well, over here what it does that these hydrogen bonds stabilize the water molecules, and basically what they do is like kind of spread them apart, right? They spread these water molecules apart, forming a nice little hydrogen bond. And what it does is that I have ice, right? Ice. And when many of these water molecules are combined, it makes a great structure. It's called the crystalline lattice. And now you can see how like this here it's water, right? Water. And here we have ice. Ice. So what's happening basically is that you can see these water molecules and they're like hydrogen bonds slip and slide. Like this one here you can see, and this one here where my cursor is. Here too they're like spreading apart, slipping, sliding. Here, and then here, and over here. This is the structure I was talking about, right? It's called the crystalline lattice, right? Crystalline lattice. That's the name of this structure, right? Crystalline lattice, and it's basically the water molecules that are like stabilized, and they form this crystal-like shape, right? They're fully stabilized. They spread apart, right? And actually, this like spreading apart and stabilizing is what makes our ice less dense than water, right? Ice is actually less dense than water, and that explains a lot. If you have seen icebergs, let's say this is the ocean, and I have like this random chunky iceberg right here sitting on top. Why is that? It's because, well, this iceberg has this shape, and then the water beneath it. Let's say this is the ocean, right? Ocean, and then the water beneath it. This water has the slip and slide liquid water configuration of water molecules. But the iceberg, right? The iceberg has a somewhat stabilized, spread apart structure than water, which makes icebergs actually float on top of water and the ocean in general. So that's what happens, and that is our basic concept of how water is arranged in the molecular structure, and how everything occurs, and why icebergs and ice floats on top of liquid water. Here, the ocean is more in motion than the iceberg since it's a solid, and that makes the hydrogen bonds spread apart. That's how we say. Again, just a refresher: the oxygen molecule, or like the hydrogen bonds, basically oxygen molecules um, bonded by their partial charges, right? I have oxygen here, and an oxygen here, and the hydrogen. The hydrogen is partial positive, oxygen is partial negative. So that makes a bond between those two atoms, right? And again, it's not like the ionic and covalent bonds we generally learn in chemistry. It's rather a weak bond called the oxygen, like hydrogen bond, right? Between the partial positive charge and the partial negative charge. And again, what would happen if like this hydrogen came across this hydrogen, which is also a partial positive? Again, they repel, right? That's basic chemistry, basic charges, right? Opposite charges repel. So that's what would happen when this hydrogen came across this one. They would repel each other, right? Until this hydrogen finally finds a compatible oxygen molecule or what atom that it can hydrogen bond with, right? And that's how the entire structure of water is formed. And again, the liquid form of H2O, water, the hydrogen bonds slip and slide like the arrows I marked over here, right? They're like separating, right? Slipping, sliding here and there. Here you can see this is a good example as well, right? But again, when we flip to the solid form of ice, they are way more stable, right? Less movement, and more spreading apart, right? The stable, the more stable the ice is, more like spread apart it becomes, and then that forms our iceberg, or like ice, whatever form of ice, right? And the iceberg hence floats on top of the water in the ocean, right? And that's generally what happens. And if you learned a lot from this lecture or just a little bit, make sure to leave a like and subscribe to this channel for more great information about chemistry, maths, physics, if I can do, right? Thank you.